Over to you, sir. Thank you. Are you there? Can you hear me? Not yet. On. Okay. Can everyone hear me? So you can at least get started. Or waiting for other people to join. Saidu, can you hear me?
Yes,
Can,
you can hear me, sir.
great. Thank you. Uh, so what I can do, let's get started. I introduce the Africa in general, and once someone from Nigeria space is available, I can stop by and maybe give us the whole context of the training. Thank you for allowing me this opportunity. And once again, good morning and good. And as I said, I'm Joseph Tuishimire. I'm in charge of capacity and user engagement within the Africa. And I prepared this with my colleague, Kenneth Mobeya, who's in charge of capacity development within our institution. And also we thank the Nigerian Space Research and Development Agency for giving this opportunity to connect with the whole team today. I start by introducing South Africa for those who hears about us for the first time. And first of all, the Africa, it's a program that was born from geoscience, Australia, and the idea was to uh, capitalize the potential of freely available Earth observation datasets um, by making them freely available in analysis the format, and also putting in place a cloud computing infrastructure that could people to uh, access and analyze those data sets, but also in a free and interoperable way. And you have a lot of capacity building programs trying to empower governments to use the data sets to inform several uh, initiatives aiming at adapting and mitigating climate change impacts, and of course, ensuring food security across the whole continent in general. But today, we'll be talking in the context of Nigeria and some West African countries. So now we have approximately 5 petabytes of data hosted in Africa on AWS server in South Africa, and all services products were developed in collaboration with partners across the continent. We currently have the Afrogist Regional Center in Ife, in Nigeria, and the guys have been doing a great job in co-developing, capacity building, and uh, other stuff in Nigeria and also in the region. I remember last time they had a training with the Ministry of Agriculture of Nigeria, and that was a very great achievement. And we've developed several products and services that cover the whole continent. And now we have the geomats. Those are cloud-free mosaics that were derived from Landsat 30-meter resolution with a longer term series from 1980s to nowadays, or also from Sentinel dataset from European Space Agency, and with a higher resolution. 10-meter resolution, but with a limited time series because our archives start from 2017 to nowadays. We have the cropland extent map to uh, map cropped areas across the continent, where the functional cover and even climatology to inform the trends in plants and crops in general. Where the water observation from space. Uh, can you hear me, please? Please, can you hear me?
We can hear you. We can hear you. Go on.
Oh, great. Oh, great. Thank you. Okay. So I was talking about the water observation from space. That product was developed for the long-term water monitoring across the continent and also the coastal service to understand the trend of the African coast, but also the impact on both the uh, infrastructure and also coastal ecosystems across the continent. So our principle is very simple. We receive data from the space agencies. Those are data providers. We process them into an analysis ready data format. Then you host them on hard space. For people through an open data cube technology, they could access them and do the processing either on a cloud or even export them and use their PC, also even their local servers. Everything is completely free, even for commercial use. You can work either on a cloud or even uh, use your PC. Data cover the whole continent, and also we have a free online learning platform that was developed with approximately now 11 courses available in French and English, just to build the capacity of users. And of course, we can start from simple analysis to even the most complex analysis to understand uh, the trends of SDGs and also from baseline towards the achievements. So our data, as I said, cover the whole continent. We use an open data cube technology, mean that you can specify just your level of interest and run your analysis on the cloud just for your own area of interest rather than for the whole continent. And of course, we have several notebooks, several Jupyter Lab notebooks that were developed. Either when you're a programmer, you can maybe add out them, but even if you are not, you can specify the time scale and also the spatial extent for analysis, then run immediately and export your results. Out about these products, I want to come back to them, but they are continental scale products, and they are decision-ready automation-based services that provide local relevant information and insights to address social, environmental, and economic changes on our continent. This is an example of WOF's dataset, or WOF's service. It helps us to understand water extent at continental level, and it translates water observations from space into an easy to consume information on the presence, location, and influence of water in Africa. And this can help countries across the Africa to map, visualize, and take decisions on the management of water resources and through thanks to a better understanding of trends over time. We can also use our platform to understand the crop phenology and extent, and this product could use vegetation indices like the NDVI, that's the normalized difference vegetation index, and the EVI, that's the enhanced vegetation index, just to compare the crop phenology at the start of the season, at the peak of the season, and also at the end of the season, trying to understand which year had probably a good yield, and also you can com- combine both true color and vegetation index to understand the true vegetation health. The question service that was developed by the Africa science team adopted from Geoscience Australia, what that was recalled, that was through the uh, Australian coastlines, helps us to understand interactively coastal erosion hotspots, rates of changes, average yearly shoreline change. Even we can estimate uncertainty just to understand the level of performance for all data sets. And of course, it's not only to monitor the changes, but also impacts on infrastructures and coastal communities in general, even ecosystems. So this is an example how it can identify the hotspot in the road, but also the rate of change in meters. And it can also, some of them would be of good quality, and others could be of poor quality. But overall, we can understand the changes across um, several corners around the African coast. We have what you call the water bodies service that's able to generate shape files for water bodies. We have identified as approximately 700 unique water bodies over the continent, and it is updated on a regular basis just for people to understand the trend in water bodies across the continent. And this is possible. It can be also applied in Nigeria, as we'll be seeing in the next. So the Africa, through all these products and the ones that we mentioned, it has three main stages. So the enhanced predictive analytics, this is the integration of uh, artificial intelligence and machine learning with EU data for improving the route, flood, and crop forecast. We can support early warning system with a higher accuracy. We can also we always collaborate with the regional partners to operationalize, but also to adapt all the pre-developed models. Also, we should always provide the more accessible, contextualized tools. Of course, people think we can even go beyond what you do using your data set until the mobile uh, phone, just for um, easily consumable information. And of course, we can embed EO insights into existing former, even environmental protection, even coastal management advisory. And multiple times we use a participatory design to ensure truths meet on the ground realities. Even for Nigeria, I don't think the southern part of the country, while they see doing the same approaches as in the central, even for the northern parts, which are mostly arid. And of course, We should always foster partnership. We should also expand capacity building and support local entrepreneurs to leverage the Africa data for climate change. For today, we'll be focusing on the third part of the capacity building and trying to share the advance in the Africa EO technologies with um, people from Nigerian Space Research and Development Agency and partners. Here are some examples. For the Africa, we have a lot of achievements. That's a kind of biodiversity conservation, trying to combine water models, identifying the floods, just to inform the biodiversity conservation. You know, the case of giraffe conservation in Lake Baringo, where this island in the middle world was being invaded, and the giraffes had to be taken away just to preserve their communities. And this was just inspired by the time series analysis using the Africa platforms. Some uh, lake water and hillside management projects like this Lake Balingo in Rakingami in Lower Okavango Delta, that was Botswana. You see how the lake has been impacted uh, from 2008, 2013, the water was increasing, 17 started decreasing, 2021 it was worse. Then we read that this was due to poor uh, management of the hillside due to uh, inadequate agriculture practices, and that's why Professor Kelebogile and the team have initiated the sustainable hillside management project, integrated watershed management plan, and just to overcome this challenge. So the coastal risk vulnerability, that's the example of KwaZulu-Natal, Tingera River mouth, using the Africa platforms, and guys were able to inform the sustainable coastal or coastal ecosystem, coastal area management using uh, or relying on evidence-based from Earth observation and geospatial technologies in general. But once again, when we interpret the use of EO datasets, we should always think about the quality. Due to data availability, some of the shorelines should be of good quality, others should be of low quality. And then when we do the analysis, you should take this into consideration. And this was the example of some uncertainties due to uh, man-made phenomena in Nigeria, especially the infrastructure, confusing the sands, beaches, even the port with the shore surfaces, or even more. So, but also we can use this platform to inform the agriculture monitoring and productivity, trying to combine both the crop land extent and the crop health, using different vegetation indices, using water availability, and many more, just to inform, even to follow up with several crop performance, even to estimate yield in some areas. But also the inclusion and diversity is very key. That's why we try to technical challenges across the continent, like bringing on board youth mappers, African Human GIS, and the last time it was the the G20 challenge, and also currently the Africa Earth Observation uh, Challenge, and many more. Just make sure we bring everyone on board, and we try also to uh, operate in many languages. We are currently operating in French and English, and now trying to add Portuguese and Arabic. Just make sure that we are serving everyone across the continent. Now that you know some of the African data sets, but how can we access them? The first way is to use the Africa map. It's an interactive platform through which we can explore data sets that are available within the Africa, uh, and they also try to do some exploratory analysis, and later on be able to inform several decisions. So if you go to your browser and and type the maps dot the Africa South Africa dot Africa, I'm sharing the link into the chat. What you'll see an interface that looks like this. Then you can get started. It has an introduction and introductory part about how was it
how that how
how this was initiated,
how this was shared.
and also uh, how it works and so on. But the most important part of this platform is that through this one you can explore data sets, but also in the setting part we can specify the background we want to have. As here I've chosen this one with the last map, even um, boundaries of countries, and you can choose the language that's available in the French and English, and we can start enjoying the platform. So we have two data sets in this the Africa maps. The first one is the data set that were generated by the Africa team. And through this data set, you have the coastline I was talking about, that talks about the coastal erosion. We have the water bodies that help us to understand the water extent using shore files, agriculture, especially the crop extent, the geomads. Those are the cloud-free mosaics that were derived from Sentinel-2 and Landsat images. They may be either annual geomads, semi-annual, even monthly, what you call rolling geomads. With the surface water, try to understand long-term water extent, and also with the vegetation, uh, trying to add vegetation data sets, land cover maps from several sources. And also, that's why we have generated professional cover in NDVI and anomalies, and energy climatology, and so on. Those are data sets that were generated by the Africa team, but also, this is the era of big data, and data interoperability is very key. That's why also we have indexed some data sets from other sources, like this high resolution data sets, like Planet NICFI data set, Africanopolis or on green space, some data on elevation, some land cover maps from various sources, uh, data meteorology like rainfall, some raw data sets, from radar, optical, even surface temperature, some data on urban settlement, some data on vegetation, especially the mangrove vegetation. So whenever you go into this Africa platform, you we have access to this set, um, and you can either, for example, when you add this coastal erosion, you can see that we are displaying this as assets. And if you go to Nigeria here, you can try to see some how some coasts have been behaving over time. In red, they are hotspots, while in blue, they are cold spots. We can keep having a look at them, not only the changes, but also the rate of change, even the confidence interval. And you can zoom onto a single shoreline. And even on a single click, you can identify the shoreline for each year. You can even show the raw data, and you can even download this in the table. And this is very key. And I can share this with you. I can copy this native link and share it in the chat. So actually, I was talking about the Africa maps, which are very interactive, but also we have the sandbox, which is a robust cloud computing interface through which you can do several analysis. So yesterday I sent you uh, a, a link uh, on which you had to try to register for the sandbox and then the sandbox account. But if you didn't do this yet, there's no problem. Uh, I want to show you how. So the sandbox, to access it, you should type in the chat in the browser the sandbox dot digital Africa dot Africa. I'm sharing the link in the chat. And when you click on it, there is a page that's going to open, to pop up, and it gives some of the directives in the two languages. That should be um, uh, in French and English. And then if you have an account already, you just log in. But if you don't have any, you sign up. So to sign up, you need to have to put all this information from your names, gender, age category. We want to have the precision on age. Some people don't like to provide all that information. Your email, please put the email for which you remember the password, as an activation code will be sent through your email. Your mobile number with the code, country code. You choose once again a password you remember, and you confirm the password. You add your organization type, being either government, academia, private sector. You choose the theme of interest. You can choose as many as you want, and also choose the locations for your analysis, and set a time frame. You can choose as long as you want, and then this is how did you hear about this, and you can create your account. So once you create an account, an activation code will be sent via your email. I was talking to Dr. Laide. He told me some of you didn't issue the code, but I advise you check uh, your spam folders. Sometimes it could be the VATI there. And if not, we'll be here to assist you on how you can you can access the code. You can create the sandbox. But also You can use the kind of softwares like ArcGIS or QGIS just to integrate the African dataset with your own data on your PC. And once again, our our online learning platform that is on learn uh, dot digitalafrica.org. I'm sharing it in the chat. Could help you to understand the platform because we have a course called the Introduction to Digital Africa Platform. This is very generic, trying to teach you to the basics of Python coding, but also to the Africa interfaces. And then we have some courses, water resource management, agriculture and food security, urbanization, land degradation, coastlines. Uh, um, this is the one side about water resources, even agriculture kind of combination, and climate action toolkit. And currently, we have also added a course that was added on the 13th of October about the EMI water data project for water balance and irrigation through South Africa. And please feel free to have a look at these courses because they could equip you with strong skills to work with the Africa platforms. And also to make life easier, we have made the data set available via the Africa Geo Portal in collaboration with S3, and you can easily work with ArcGIS online, even on data sets, and the tutorials were provided. You get them through this presentation as I be sharing it. But also with the metadata explorer, through which you can explore the existing data for any given area. You know, African continent is crowd, and you should be able to check available data for a specific date and for a specific region. And each grid could have uh, key clear data sets over time. And of course, you can check also for APIs just to transfer directly data sets from the Africa platforms to your local servers without necessarily going through all stages to download and store data set, which would be a burden due to space requirements. So I was talking about the Africa maps. I come back to show you how they work and some key explorations we can do. If I go back to the Africa uh, maps, is I was showing a few minutes ago, I was able to explore some areas um, like this. This is a mangrove areas near Wadi Southwest. I think yes, Wadi Southwest, and I was trying to see how this vegetation was behaving over time, and what I did, I used the Sentinel-2 geomat just okay, and also I've instead of using the true color images, I tried to use the vegetation indices, the NDVI, to understand how this is how the region looked. That was in that's on the first in 2024. This is the annual geomat, but you also can check for 2017 it looks less greener and less green, if we can say. Then we can do some comparison, compare 2 years. You can compare 2017 to maybe 2024, and just this is 2017, this 2024, 2017, 2024. You can see that this part down here has improved in terms of NDVI or in terms of greenness. To me, that the mangrove vegetation was more or less destroyed in your area. And I can just copy the link and share with you in the chat just for you to explore the same way I'm exploring this. And last time in collaboration with the Afrogist Regional Center, we worked around this river, Lokoja. And if we see our river Lokoja here, so this area has been flooding and it has been affecting both this activated lands in the middle, but uh, also these settlements on the uh, upper left, and even those croplands in uh, the lower right of the region. So we can try to understand the water extent over time. Either we can use our surface water for long-term monitoring. We can use this water observations from space, and these are based. Those are projects were aggregated from Landsat datasets on annual basis, a kind of annual median, annual aggregation, annual summary, and also from 1984 to nowadays. And we can either try to understand the water frequency. In reddish should be um, temporary water, while in blue it's permanent water. And you can see this down this part down here, even the central is frequently floods, but also around here around the settlement there are some flood events over time. We can compare some years. Let's say let's compare maybe uh, let's compare maybe 2019 and 2024. This is 2019. You can see that how 2024 became flooded. And this is very key because we're able to inform some management measures. We can even create a story from this and that story, maybe flooding in Lokoja. Then we say 2024 more flooded than 2020, 2019. Then we can save and they can once again copy the link and share it with you in the chat so that you can view it the way I'm viewing it myself from this screen. And this is the power of the Africa map, very interactive. And if you go into the sandbox, if you're able to create an account, um, you just get in, and when you get in, you have some many folders. The first one is the beginner's guide that has a lot of some few notebooks introducing to Python coding in general and the Africa platforms. And they have data sets that shows us how data sets we have and how they are processed. And you have the frequently used codes, just some key codes to generate indices, to do some component analysis to export data sets and so on. The real world examples, this folder is very key because it gives us notebooks with a full description and for each theme from water resources and flood risk mapping, vegetation cover monitoring, crop health and phenology, and so on. And for use cases, it's where once your work is successful, you can share it with the community just for them to benefit and use them either duplicate the code or even improve or build on your work for their analysis. So when you go to the sandbox, um, there are several themes. Today, I'll be introducing them theoretically, and from tomorrow, we start to work theme by theme. Now we have the agriculture and food security. Uh, we have notebooks that prepare to monitor the crop health using net2 datasets, and you have the crop extent map to able to understand the crop extent because the whole continent we could understand the monthly vegetation conditions and anomalies, and using both Landsat from 5 to 8 data sets, and we can also understand the vegetation phenology using either optical sensor and through NDVI and EVI, or using the radar sensor. That's what you call the radar vegetation index. That is RVI. So all those data sets, all those workflows are well documented and located in a known folder. We have a clear set as input, and of course, they are mostly linked to SDGs, SDG 2, of course, zero hunger and others. So if we talk about the vegetation health or crop health, we have this way of combining the spectral signature for uh, several plots of one field. And if it's the same in terms of NDVI, that these parcels are performing the same way for our region. But if not, we should be able to inform the manager of those fields or even extensionists to go and cross-check what happened. Either the inputs were not of good quality, I mean fertilizers and seeds, either agricultural practices were not well respected, or even there is water stress and other climate change impact. Even there should be some pests in that area. And this is very key to inform the kind of management, but also we can understand the vegetation phenology using the optical sensors, trying to understand the season, the peak of the season, and the end of the season, and comparing many years just to understand how crop has been behaving, but also could understand other statistics like the length of the season, even the amplitude of the season. We can do this using both optical sensors and radar sensors. Just in case, radar sensors are better because they could penetrate the clouds, and this is very important in the tropical Africa with a lot of clouds. You can also develop some models that this armor, and this is a good model as compared to build a model and even to validate it. And most importantly, it could include some exogenous variables and inform some crop management over time. So sometimes it's better to combine the map, a dynamic map, with the rainfall anomalies just to understand how the climate or even seasonal change or variability could affect the crop health in a given region. And this kind of analysis can assist in assessment of crop production in a given year, and it could be fed into another warning system and forecast on crop production and food security. This was the case of Madagascar, but for the practice, we try to focus on Nigeria. So burnt area mapping, it's also something that could be done, trying to use the normalized burnt ratio to understand um, uh, which are the areas that were affected by bushfires. We should remain with those master areas and propose some intervention measures. Imagine we are about to put maybe a fire brigade in this area, then the northeastern part, the west, the far western part, even the south western part should be the key areas of intervention. And this is about to optimize the fire control in a given area. But also for water resources, that was about food security and vegetation in general. But for water resources, we can monitor wetlands in Africa. We can monitor water extent either on a long term using WRFs or even by season using the SNA data sets. We can also monitor the water quality either using the profile um, proxy, but also we can also monitor the quality in terms of the total suspended matter. And now we're trying to understand the lake water quality. And recently, a notebook on this was read by our science team. This is an example where we can see, we can try to understand how any lake water uh, has been behaving over time. We can see that our dam has been shrinking over time. The same applies for our lake Baringo, where the water has been expanding over time, as you can see in the elevation, affecting both the nearby biodiversity, especially the giraffes that had to be relocated just to save their life. So also we can see this on the map, as I was showing you about River Lokoja, and you can compare several years and then even share this kind of links. I've done this before. I'll talk about Lokoja. I wanted to prevent this session. You can see you can produce next time series to see how our river Lokoja has been flooding over time from 2002 until 2024. And you can see that over time, it's like the river Koja is colonizing these areas inside. And of course, if we try to compare 2019 to 2024, there's a good news that water has been decreasing, no more flooding. You can see a balance of approximately 1.3 kilometer, uh, square kilometer that was gained in terms of uh, land, and then you can produce this next time series showing on the graph how the river has been behaving per year. But you can see that recently our river has been unstable and with ups and downs, and of course with the high risk of flooding are affecting both the the population in the settlements, even being a cause of food insecurity because it could damage some crops other than the central part, even down here. And this was done using long-term WOFs products, but also uh, this was based on the water indices, water index, modified normal difference water index, but in combination with the digital elevation model. And you can also go until the level of seasonality analysis using the SNA2 term series in your archives. And this is the example in combination with the AfriGist, we're able also to go and try to understand how the flooding of this river Lokoja could impact both the settlements and even the croplands. And we came up with the land use map from the European Space Agency land cover map. Then we classified areas from depending upon the level of risk and vulnerability, and from highly prone, high flood prone to unaffected areas for both croplands, even um, settlements. So sometimes you collaborate with the partners, you have to develop some solutions and leveraging from ongoing initiatives. That's how we collaborate with the IMI, that's the International Water Management Institute, and use their data sets from their projects in Ethiopia, Ghana, Burkina Faso, and Zambia just to make this analysis available to the community of users. And now have two courses available in French and English on how we can manage water resources just for sustainable food security uh, in our countries. Of course, I think about the S3 Africa Geoportal audits were made available, and we have a lot of tutorials. Please feel free to have a look at them. And also we have a part on the urbanization. This is the third aspect. The first one was agriculture and food security. Second was water resources. The third is urbanization. You can do some urban detections. Also use the urbanization indices. And this is an example of how you can use the urbanization indices so to understand the urban growth over time. Like this was the case of Windhoek in Namibia. That's uh, expand from 61 to 78, almost 17 square kilometer over 4 years. And if we try to simulate over time, we can inform some urbanization policies, but also we can compare several ways of mapping the expansion of urban areas using several proxies, and of course be able to overdate them to see which streets uh, our region. You know, also the concept of green urban areas is very key nowadays because we intend to increase the tree cover and green spaces in urban areas. And that's why, in collaboration with the West Africa Club, say the West Africa Club, we're able to leverage from uh, our free available land cover maps from Open Space Agency and try to understand the dynamics of green spaces. You can see the green, even the tree cover in some cities. And you can see this is the case of Kumasi, Ghana. You can see that between 2020 and 21, you can see that is the trend is promising, and you can classify this as a city that is enforcing the concept of the policy of green city in our region. Also, the fourth one should be the coastal erosion and the mangrove vegetation monitoring. So some notebooks on the mangrove analysis, coastal erosion were already made available to us, and you have a time to explore them, but to almost to understand the dynamics of mangrove vegetation, but also to understand the trends in coastal erosion. This was example of mangrove vegetation in Greek, but also I've shown you some of them in Nigeria using the African maps, where you can understand the mangrove with no change, the loss in mangrove, um, the appearance of some new mangrove, even the delta change, and you can see overall we had a loss of few square kilometers of mangrove, and you can produce a kind of change detection map and to inform the management of mangrove. The coastal erosion, so able to understand the trend or annual trends of the coastal erosion, as you can see, and you can also understand cold spots and hot spots. But once again, if the Africa had developed the dashboard that could help us to understand the coastal erosion, if erosion or accretion for each country, but also the mighty population within less within 1 kilometer, but also uh, uh, some population with 1 kilometer, but they're lying in flat areas, mean that in less at least than 5 meter above sea level, that could be easily impacted by um, the coastal erosion. And this is very key because it's a dynamic way of assessing the coastal erosion in a region. And I'll share this link in the chat. So lastly, there are a lot of other stuff like the ship detection, land cover classification, surface mining. All those phenomena could be explored using the Africa platforms. And this is an example of land degradation map. We did collaboration with the OSS, and the module was made available uh, on the DAfrica learning platform. You can feel free to have a look at it. So this also the land degradation, land change detection map, where extent there's improvement, stable, no change, wild bird. Those are, in other words, degraded areas. And this was true on 14, 2019, 2014, 2019 too. And you can see how the map was looking after refinement. And of course, on the right, those are true color images. Surface mining, try to understand how the mining sites are affecting natural vegetation. That combines the Sentinel-2 archives and even the water observation space, just where we have appearance of water and disappearance of vegetation. It's probably a mining hotspot, and this could inform the management of natural reserves like this Pamplama first reserve in Ghana that was affected by people doing illegal gold mining, known as galamsey. the local um, context, and then this informed the management. I can understand the trend of vegetation loss. Vegetation loss probably due to mining. You can understand areas that were affected by mining on annual basis, and this could be able to inform the the management. So we collaborate with the partners. So the geology hub, all the tutorials are online. If you go through the elected links, even the ones we are doing with ourselves could be made available to the public. And of course, our learning platforms, our our tutorials available for every course. We have some discussions every Wednesday during our live session. Feel free to log in. And most importantly, uh, if you like to know more about the Biafka platforms, you check our user guide. On user guide, you have the Africa products, all the products and services I've been talking about, the descriptions from the input data set, production processes, validation would be found here, and also the capabilities and limitations were documented and shared with the whole team. The platforms, you can have them, see which platforms we have, and from the map, a sandbox, and the metadata explorer. Please have a look at them. I share the links in the chat. Um, and once again, the direct access, how to directly access to the Africa datasets, and either through APIs, Google Colab, and other ways of data access. Please uh, have a look at this. And of course, you can also visit our social media just to uh, make sure you capitalize uh, the potential of the Africa platform. We thank all our partners, and of course, for more inquiries, you can scan the QR code and send us your feedback, even reach out to myself and can just for data assistance. So thank you. That was it for the introduction for today, and this time for discussion, exchange, challenges, because tomorrow we should start uh, 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 by our first topic, uh, which according to uh, the timetable today, it was the intro. Everyone should get the Sandbox account at least. Tomorrow we'll have a practical session on agriculture and food security. After tomorrow, let me go to full screen. After tomorrow, we have another session on water resource management, flood mapping, and water extent. Thursday, it will be urban growth and coastal erosion. And lastly, we'll be able to develop a use case depending upon each the ground, the background of each participant. So uh, over to you just for discussion intervention. You are the most welcome. Thank you.